When a tertiary or secondary alcohol is heated with a powerful acid such as sulfuric acid or phosphoric acid, an alkene is produced through a mechanism called the E1. In this example, tertiary butyl alcohol is heated with sulfuric acid to produce 2-methylpropene and a molecule of water. While the reaction is not favored enthalpically, it is favored entropically, and the elevated temperature is used to increase the role of the entropic factor. This also allows for distillation of the lower boiling alkene product, thus driving the equilibrium to the right-hand side. Elimination from the alcohol to produce the alkene is known to be a stepwise process that begins with the protonation of the hydroxyl functionality to provide a better leaving group. This then breaks off to form an unstable carbocation. The intermediate then loses a proton from the beta position to give the alkene product. Since the acid makes the reaction go faster and is consumed in the first step and regenerated in the last step, the mechanism is then catalytic in acid. Since the reaction is performed under acidic conditions, the first step will be protonation of the weakly basic alcohol by the strongly acidic catalyst. This gives the protonated alkoxonium species, and this step will be fast and reversible. The endothermic rate determining step follows, in which the water leaving group breaks away from the alkoxonium species to produce the tertiary carbocation. Since this slow step only involves the collapse of the protonated alcohol, it is therefore unimolecular. The unstable carbocation can then reattach to a water molecule to go backwards in an SN1 nucleophilic attack. Alternatively, the carbocation may lose a proton from the beta carbon with the solvent water acting as a base. This results in the alkene product. Higher temperatures favor the alkene formation and allow for its isolation from the reaction mixture by distillation. To summarize, when a tertiary or secondary alcohol reacts with a strong acid, such as sulfuric or phosphoric acid, at high temperatures, alkenes are formed. Overall, this is the loss of a molecule of water from the starting material to give the alkene. The reaction is known to be catalyzed by the acid and is described as the E1 process, in which the rate determining step is known to be unimolecular collapse of the alkoxonium intermediate to the carbocation.